If you have ever built search in your app using simple like queries, you are doing it wrong. Because in this video, I will show you how to build a powerful full text search using Supabase and PostgreSQL with ranking, highlighting, and Google-like behavior. So here I have a simple products page. As I type, you can see the results updating instantly. It even understands natural language. For example, if I search red cabbage, you can see we still get the result, even though in the database it stored as organically grown red cabbage. Now in the database it stored as fresh onion, but even if I change the order like onion fresh, I still get the correct result because full text search doesn't depend on word order. I can also remove unwanted results. For example, if I want capsicum but not red, I can simply type capsicum minus red and you can see it removes red capsicum and shows the rest. And if I want exact matches, I can use codes. Let's search fresh onion and this will only return results where the exact words match. Notice this, matching keywords are highlighted automatically so users can instantly see the relevant parts. And also results are ranked smartly. Better matches appear on top based on relevance. And the best part, this is all powered by PostgreSQL. No external search engine needed. Now let's break down how this works step by step. Now let's start building. As you can see, I already have a products page and a search input, but if I type something, nothing is happening right now. So in this video, we are going to implement full text search step by step. First, let's go to Supabase and open the database that is connected to our project. So here's what we are going to do. First, we will understand how full text search works using the SQL editor. Then we will take that same logic and implement it inside our project. And finally, we will make it production ready with ranking, highlighting, and all advanced features. So let's get started. First, let me show you the products data on which we are going to implement full text search. So this is my products data. As you can see, we have fields like name, description, and other details. And this is exactly the data our search will run on. Now, let's head over to the SQL editor and start implementing full text search step by step on our products data. First, let's select everything from our products table. To access a table in PostgreSQL, we use the public.tablename format. Now, let's add a condition to perform full text search. Inside the where clause, we use 2ts vector. We pass English because it tells PostgreSQL to use English language rules, like ignoring common words and handling different word forms. Then we pass the column we want to search in. For me, it's the name column. Now, what is TS vector? TS vector is basically a converted version of your text. It takes normal text and transforms it into a format that's optimized for searching. Next, this double at the rate operator. This is the match operator. It checks whether the searchable data matches the search query. Now, on the right side, we use 2ts query. Again, we pass English for language processing. And then we pass the user search input like fresh onion. So what is tsquery? Tsquery converts the user's input into a format that PostgreSQL can understand and search against. So overall, on one side we convert our data into a searchable format and on the other side we convert the user input into a query format. And the match operator checks if both match. Now let's run this query. And you can see we got the product in the result for the search fresh onion. Now, one more important thing. We are not limited to just one column. In real-world applications, we usually search across multiple fields, like both the product name and the description. And the good part is, full text search supports multiple columns as well. So instead of searching only in the name, we can also include the description. Just make sure you add a space between them while combining, because without a space, both fields can merge into a single word, which can break the search and give incorrect results. This makes our search much more powerful because now it can match results even if the keyword is not in the name but present somewhere inside the description. Now, one more important thing. Right now we are using 2ts query, but PostgreSQL actually provides multiple ways to create search queries. There are mainly four methods. First, 2ts query, where we have to manually write operators like and or not. Second, plain to TS query, which automatically converts plain text into an AND-based query. Third, phrase to TS query, which is used when we want exact phrase matching. Fourth, web search to TS query, which supports a more natural web style search syntax. Now, the problem with the first few methods is they are not very user friendly. Users don't type search queries like operators, they just type normal text. That's why in this tutorial we are going to use web search to tsquery because it supports things like natural typing, codes for exact match or conditions and even negation. Basically it behaves much closer to how real users search on the web. So in the next part, let's explore its advantages one by one. Now let's replace to tsquery with web search to tsquery. First, let's try a simple search. Now let's search fresh onion and you can see we get the correct result without using any AND operator. So now we don't need to manually add operators anymore. Next, let's try a more natural search. In our database, we have organically grown red cabbage stored. Now, first let's search organic grown red cabbage and you can see we get the result. But if I search organic red cabbage and run this, you can see we still get the result. Even if I simplify it further like just red cabbage, it still returns the correct result. This is a huge advantage because users don't always type exact text. Next advantage, order doesn't matter. In the database we have fresh onion, but if I search onion fresh, you can see we still get the result. Next, negation. Let's search for capsicum. You can see we get multiple results. But what if we want capsicum but not red capsicum? Simple, we use negation. Just type capsicum minus red and run the query. Now you can see it excludes red capsicum and only returns the other results. Next, phrase search. If you want an exact match, you can use double quotes. Let's search organic red cabbage. You can see nothing is written because in the database it's stored as organically grown red cabbage. Now if I search the exact phrase, you can see it returns the exact product. Next, shape parsing. If a user types something messy like fresh, and onion, PostgreSQL automatically cleans and sanitizes the query and still gives us the correct result. So these are some of powerful advantages of web search to tsquery. It allows users to search naturally without worrying about syntax or operators. And that's exactly why we are using it, because it gives a much more real-world Google-like search experience inside our database. But there is still one problem. Right now this is not production ready because every time we run a search query, PostgreSQL is recalculating the TS vector on the fly. And that's not efficient, especially when your data grows. This can slow down your queries significantly. So what can we do instead? Instead of generating the TS vector every time, we can store it inside the database itself. Basically, we pre-compute the searchable data once and reuse it whenever we perform a search. This makes our search much faster and scalable. Now let's make this production ready. Instead of calculating TS vector again and again, we are going to store it inside our database. So first, let's create a new column called search vector. We will add this column to our products table. So let's alter the product table and then add a column called search vector and its type will be TS vector. Now let's run this. And you can see we get a success message. Now let's quickly verify it. Let's go to our products table and you can see the search vector column is now created. But right now all the values are null because we have only created the column. We haven't filled it with the data yet. So in the next step we will populate this column and make it actually usable for search. Now let's populate the search vector for existing data. Right now the column is empty. So we will update all existing products and generate the search vector for each row. What we are doing here is we are combining the name and description, adding a space between them, and then converting the whole text into a searchable format using 2ts vector. Now let's run this, and this will fill the search vector for all existing products. Oh, we got an error. It says the search vector column already exists. That's because we already created this column in the previous step. So to fix this, just comment out the add column query and run the update query again. Now let's go back to the products table, and if you check the search vector column, you can see the vectors are now generated. So now all our existing data is ready for fast and efficient full text search. Now let's create a trigger, because whenever a new product is added or an existing product is updated, we want our search vector to update automatically. So first let's create a function. We will call it product search trigger. This function will return a trigger because it will be executed automatically whenever an insert or update happens. And we set the language to PLPGSQL, which is the language used to write functions in PostgreSQL. Now inside the function we begin our logic block. Here we are setting the new search vector value, so whenever a new row is inserted or updated, we take the name and description, combine them with a space and convert them into a searchable format using 2ts vector. And finally, we return the updated row. So what this function does is, it automatically keeps our search vector in sync whenever data changes. So now we don't have to manually update anything, it happens automatically. Now let's create a trigger. We will call it product.ts vector update. Next, we specify before insert or update. That means this trigger will run before a new product is added or an existing product is updated. Then we define the table, so this trigger will run on our product table. Next, we write for each row, which means this trigger will run for every row that is inserted or updated. And finally, we execute the function product search trigger. So what this trigger does is, whenever a product is added or updated, it automatically calls our function and updates the search vector. Now finally, let's create an index, because as our data grows, searching without an index can become slow. So to make our full text search fast and efficient, we create an index on the search vector column. Now let's create the index. We will call it product search index. Next we specify the table, our product table. And here we use GIN. GIN is a special type of index that is optimized for full text search. And finally, we apply it on the search vector column. So what this does is, it makes our search queries much faster even when we have a large amount of data. So now our full text search is not just working, it's fully optimized and production ready. So let me quickly show you what we have done so far. First, we created a search vector column to store our searchable data. Then we populated this column for all the existing products. After that, we created a trigger, so whenever a product is added or updated, the search vector updates automatically. Oh, one small thing I missed. We need to use new.name and new.description inside the trigger function, because we are working with the new row values. And finally, we created an index to make our search fast and efficient, even with large amount of data. Now let's go back to our search query, and instead of using 2ts vector, we will use our search vector column. Now let's run this and check if it's working. And you can see it's working perfectly. And the best part is, now we are not calculating anything on the fly. We are using our pre-computed data, which makes our search much faster and production ready. Now let's talk about weights. Weights helps us control which fields are more important in search results. In simple terms, not all data is equally important. For example, a match in the product name should matter more than a match in the description, and that's where weights comes in. PostgreSQL provides 4 weights. A has highest priority, B has high priority, C has medium priority, and D has lowest priority. So what we can do is, we can assign higher weight to important fields like the name and lower weight to less important fields like the description. So let's go to our setup. Inside the update query, we will write something like this. We will give A weight to the name and B weight to the description, which means the product name will have more priority than the description. Now just copy this and paste it inside the trigger function as well. Just one small change here. Make sure to use new.name and new.description inside the trigger function. So now our search is not just working, it is also ranking results intelligently. Now let's run this. And now let's go back to the products table. If you look at the search vector column, you can see the weights applied in front of each word. The words coming from the description have B weight and the words from the name have A weight, which means name has a higher priority than description in search results. Now, to actually see the benefits of weights, we need to implement ranking. For that, we use tsrank. Inside tsrank, we pass our search vector column and the search query using web search to tsquery. And we will store this value as rank so we can see how relevant each result is. What this does is, it calculates a score for each product based on how well it matches the search query and also considers the weights we assign. And finally we return the products in descending order of rank, which means the most relevant results appear at the top. Now let's try a simple search. Let's search for fresh. And you can see we get multiple results. Now if we scroll to the end, you can see the rank column. Notice this, the first result has the highest rank and the other results have lower ranks. Now you might be wondering why. It's actually very simple. If you look closely, in the first result, fresh is present in the name, but in the other results, fresh is present in the description. And if you remember, we gave A weight to name and B weight to description. So that's why the result where the match is in the name gets higher rank compared to the ones where it matches in the description. And this is exactly what we wanted, more relevant results appearing at the top. Now there is one more powerful feature in full text search, which is highlighting the matching keywords. To implement this, we use TS headline. TS headline basically takes your text and highlights the parts that match the search query. So instead of just returning results, it shows exactly where the match is happening. So let's use it. We will create two new fields, one for the highlighted name and one for the highlighted description. Now inside TS headline, we pass English for language processing, the column we want to highlight like name, the search query, and then this configuration. What this does is, it wraps the matching words inside HTML tags, so here we are using mark, which will highlight the matched text. And we will name this as highlighted name. Similarly, we will do the same for the description. Just replace the column with description and name it as highlighted description. So now we are not just searching and ranking, we are also visually highlighting the matches for the user. Now let's run this and scroll. You can see we now have two new columns, highlighted name and highlighted description. And notice this, the keyword phrase is wrapped inside the mark tag, which means our matching text is now highlighted visually. That's great because user can instantly see where the match is happening. Now let's test our trigger. To check if it's automatically creating search vectors or not, let's insert a new product. Right now I'm inserting it directly from Supabase, but you can also do this from your application. I'm just showing it here for understanding. Let's fill in the details. And click on save. Now you can see the product is inserted successfully. Now let's check whether the search vector is created or not. And you can see the search vector is automatically generated for this product without running any query. And that's the power of triggers. Similarly, if we update this product, the search vector will also update automatically. So we don't have to manually maintain it. Everything happens behind the scenes. Now, one more important thing. Everything we have done so far, writing queries in the SQL editor, was purely for understanding full text search in detail. But in real production setup, if you are using Prisma with Supabase, you should never rely on manual SQL editor changes. Instead, we use migrations. Now, why migrations? Because migrations keep your database changes, version control, consistent and reproducible across environments like development, staging, and production. So here is the correct workflow. You create a migration using the Prisma migration command. This will generate a migration folder inside your Prisma migrations folder. Inside that folder, you will find a SQL file, and inside that file, you need to paste everything we built, adding the search vector column, updating existing products, trigger function, trigger itself, and the index. Then you run npx prisma migrate deploy, and this is the production way. Everything gets applied in a controlled and reliable manner. So just remember, what we did in SQL Editor was for learning and experimentation, but in real projects, always use migrations from the start. Because if you mix both, if you run triggers manually in SQL Editor first and then try to create migrations later, you can get migration drift errors. So the best practice is simple. Start with migrations always. And that's the correct production approach for full text search setup. Now let's start building this in our actual project. To do that, we need to create an API that fetches products based on the user's search query. So let's create an API route. I already have a products API route set up, so I will just open that. You can structure this based on your own project. Right now, I simply fetching all products. Now we are going to change that. Instead of returning all products, we will fetch products based on the search query. So let's clean this up, remove the existing logic and start fresh. Now let's create our get function. We will assign the request as a parameter. Inside this, we will add a try catch block. In the catch block, we will log the error and return a response with message and status code. Now inside the try block, first we will extract the search params from request.url. Next we will get the query from the search params. Now we add a condition. If there is no query, we simply fetch all the products and return them as a response. But if there is a query, we will fetch products using our full text search. To do that, we use Prisma raw query. We use db.query raw along with prisma.sql. This allows us to safely write raw SQL queries while still preventing SQL injection. Now inside this template literal, we will add our full text search query. So let's go to Supabase, copy the search query we built earlier and paste it here. Now we make few changes. Replace selecting all with only the columns we need because we don't want to return search vector. Then replace the hard-coded search text with the dynamic query from search params. And finally we return the products as a response. So now our API is fully connected with full text search and it will return ranked and highlighted results based on user input. Now let's test this API route. Let's open Postman. Now enter the URL localhost/API/products and add a query param, for example q is equal to fresh onion. Now click on send and you can see we get the product in the response. Let's try another search. Try different product. And you can see we are getting the correct results again, which means our API route is working perfectly with full text search. Now that our API route is ready and working, let's integrate it into our front end. Before that, let's go to our search input component because first we need to handle the user input. So this is my search input. Right now it's static and I'm using it inside the navbar. Now what are we going to do? We will take the user input, store it in the URL as a query parameter, and based on that our API will return filter results. So first let's define the router using useRouter. We will use this later to update the URL dynamically. Next we get the search params using useSearchParams. This helps us read the query from the URL. Now we extract the query from the search params and store it as an initial query. Then we create a state called search query and set the initial query as its default value. Now we add a use effect. This ensures that whenever the URL query changes, our input field stays in sync with it. Next, let's create a handle change function and I set value as a parameter. This function will run every time the user types in the input. First, we update the state with the new value. Then, we create a new URL search params object. This allows us to update query params without losing existing ones like sort or limit. Now, we add a condition. If the user has typed something, we set the queue parameter in the URL. And if the input is empty, we remove the queue parameter from the URL. Why are we doing this? Because if there is a value, we perform search. If it's empty, we show all products. So we keep the URL clean and meaningful. And finally, we push the updated URL using the router. So now, whenever the user types, the URL updates and that triggers our search. Now, you might be wondering why not just directly pass the value in the URL like q is equal to value. The reason is very simple. If we do that, then when the input is empty, the URL will still contain something like q is equal to, and that doesn't look clean. We want our URL to be meaningful and clean. So instead, we only add the q parameter when there is an actual value, and if it's empty, we remove it completely. There is one more reason. Suppose you have other filters in your URL like sort, limit or anything else. If you directly override the URL, you might accidentally remove those. So to avoid that, we use this approach, which safely updates only the queue parameter and keeps everything else intact. So when you search something, the URL looks like this, and when it's empty, it stays clean like this. And that's why this approach is better. Now let's connect everything. Attach the handle change function to the inputs on change event and set the value as search query. So now our input is fully controlled and connected to our search logic. Now let's go to the browser and try this. So right now the input is empty and you can see the URL is clean. Now let's search something. As I start typing, you can see the URL is updating in real time. That's great because now our input and URL are perfectly in sync. Next, we will go to products page, read this query from the URL and based on that fetch the products. So now we will connect this with our API. Now let's go to the products page. First, let me remove the existing function and query so we can start fresh. Now let's get the search params. We use search params to read values from the URL. Next, we extract the query from the search params. Now let's create a function. We will call it search products. This will be an async function and it will accept the query as a parameter. Inside this, we will call our API route. Something like API/products q is equal to query and return the response data. Now, one important thing, we will use debouncing. Why? Because without it, an API request will be sent on every keystroke, which can be inefficient and cause too many requests. So to fix this, we will install and use debounce. Now we use it like this. We extract debounce from use debounce and pass the query along with a delay. Here the delay is 500 milliseconds, which means the API call will only happen after the user stops typing for 500 milliseconds. Now let's use React Query. We will use useQuery. From this we get data as products. Inside useQuery, we set the query function as search products and pass the debounce query. Next, we define the query key as products and debounce. Why? Because whenever the debounce query changes, React Query will refresh the data automatically. And finally, we set stale time to 1000 into 30. That's 30 seconds, which means for 30 seconds, the data is considered fresh and React Query won't refresh unnecessarily. Now, let's go to the browser and try this. Right now, the input is empty, so you can see all the products. Now, let's search for something. Let's try fresh onion. You can see the products update and we get the correct result. Now let's try another one. Search organic red cabbage. And again we get the expected product. Let's try something broader. Just search organic and you can see we get all the products that contain organic, which means everything is working exactly as expected. Now let me show you a more advanced pattern. Instead of handling everything inside the products page, we can move our logic into a custom hook. Why? Because then we can reuse it anywhere just by passing the query. So our code becomes cleaner and more production ready. So let's go to our hooks folder and create a new hook, use product search. Now inside this, we create a function, use product search and save query as a parameter. And from here we simply return use query. So let's go to products page, copy the use query logic and paste it inside the hook. Next, copy the search products function and paste it inside the hook as well. Just make sure to export it and import Axios if needed. Now one more thing, copy the debounce query logic and move it inside the hook. And don't forget to import use debounce. So now our hook is fully ready. Let's go back to the products page, remove the existing use query logic and instead use our use product search hook and just pass the query. And that's it. Now our code is much cleaner, reusable and easier to maintain. Now let's go back to the browser and try this again. Let's try searching for something, search capsicum. And you can see it's working perfectly, which means our custom hook is working as expected. Now, you might have noticed the search keywords are not highlighting on the UI, so let's fix that. So this is my product card component and here I have extended my product type to include highlighted name and highlighted description. Why? Because our API is now returning highlighted HTML, so we need to include these fields to render that data on the front end. Now here, instead of directly rendering product of name, we use dangerously set inner HTML. What this does is, it allows us to render HTML content directly inside the component. So in our case, if highlighted name is available, we render that, otherwise we fall back to the normal product.name. Why do we need this? Because highlighted name contains HTML tags like mark which highlight the match keywords, and without this, React would treat it as plain text instead of HTML. So now, the matching keywords will be visually highlighted inside the product name, and this makes the search experience much better. Now we will do same for the description. Just copy this code and paste it in place of product.description. Then make two small changes. Replace highlighted name with highlighted description and product.name with product.description. So now both the name and description will show highlighted matches, and that completes our highlighting feature. Now let's go to the browser and try this. Let's search for something, search organic, and you can see the keyword is now highlighted. Now let's try another one, search fresh, and you can see fresh is highlighted in both the name and the description. And this looks much better because user can instantly spot the matching keywords. Now let's quickly test everything we built. First, basic search. Let's search fresh onion, and you can see we get the exact product we are looking for. Now ranking. Let's search fresh. And notice this, products where fresh appears in the name come first, even though other products also contain fresh in the description. Next, natural search. Let's search organic red cabbage. Even though in the database it's stored as organically grown red cabbage, we still get the correct result. Now, negation. Let's search capsicum minus red. Even though there are multiple capsicum products, it excludes the red one and returns the rest. Next, order doesn't matter. Let's search onion fresh. Even though in the database it's stored as fresh onion, we still get the correct result. Now exact match. Let's search onion fresh. And you can see we don't get any results because that exact phrase doesn't exist. Now let's search fresh onion. And now we get the exact match. And finally highlighting. You can see the matching keywords are highlighted in both the name and the description. So this is a complete production ready full text search system with ranking, highlighting and advanced search features. If you found this helpful, make sure to like, share and subscribe, and I will see you in the next one.